Keeper 4.6, derivatives of logarithmic and exponential functions. All right, so our formula for the derivative of a ln x is simply 1 over x. Now, if the expression within the log wasn't just x, let's say it was like x squared or x cubed plus 7, or even like a sine x, if it was some other function, you do have to chain rule it. So you do 1 over whatever the expression is times the derivative of that expression. All right, so our first example, we have y equals ln x cubed plus 1. So very simply, I'm going to do 1 over the expression within the log, which is 1 over x cubed plus 1. And then, because of chain rule, I have to multiply that by the derivative of that expression. So the derivative of x cubed plus 1 is 3x squared. Finally, I'm just going to mush it all together, move my 3x squared to the numerator, and I get y prime equals 3x squared over x cubed plus 1. In the second example, I have y equals ln square root of x. Now, I can do it the way I just did it, where I do 1 over the square root of x times the derivative of that. But because it's an ln, I can do it a little bit easier by using my log rules. So I can rewrite it as ln x to the 1/2. And then using my power rule for logs, I can move that 1/2 to the front. So I get 1/2 ln x. Once I write it like that, I can very simply, again, just take the derivative of that ln x, which we know is 1 over x. So y prime is 1/2 times 1 over x, simplified out to 1 over 2x. All right, next example, we have y equals ln x over x squared. This time I'm going to use quotient rule. So I'm going to do low x squared d high 1 over x minus high, which is ln x, d low, that's 2x, all over my low, which is x squared squared. Simplifying that out, I get x minus 2x ln x over x to the 4th. And again, I can simplify that one more time to be 1 minus 2 ln x over x cubed. Next, we have y equals ln x. So again, I'm going to do 1 over the inside, which is ln x, and then I have to do times the derivative of ln x, which is 1 over x. That is simplified out to 1 over x ln x. Now, we can also do derivatives of exponential functions. So the derivative of e to the x is e to the x. And if the x was anything other than x, if it was any other type of function, I would just chain rule it. So I'd say like e to the function times the derivative of that function. Now, if it's an exponential function that has a base other than e, the formula for that derivative is the base to the x times ln of the base. And again, if I have anything other than x, I have to chain rule it and times it by that derivative as well. All right, so in our first example, we have e to the 2x. The derivative of that is just e to the 2x, but I have to find the derivative of the numerator, which is 2, so I would times that by 2, and I'd be left with y prime is 2 e to the 2x. Next example, we have y equals e to the 5x squared. The derivative, again, I simply just write e to the 5x squared, and then I take the derivative of the numerator, which would be 10x. And if I clean that up, I get y prime equals 10x e to the 5x squared. All right, next example, we have y equals e to the sine x. Again, I just repeat that, e to the sine x, and then I times it by the derivative of the exponent. The derivative of sine is cosine, so I multiply that by cosine, making it look a little bit prettier. I get y equals cosine e to the sine x. In our next example, we have e to the tan x. Again, rewrite that, and then the derivative of tan x is secant squared. So again, I can leave it like that, or I can rewrite it with the secant squared in front and have y prime equals secant squared x e to the tan x. And again, that should be like a little prime symbol right here. All right, now we have 7 to the x squared plus 2x cubed. Now our base is not e, so I have to use my other formula for a base of a. And so again, the steps for that is you rewrite the expression, 7 to the x squared plus 2x cubed. Then I do the derivative of the exponent, which is 2x plus 6x squared. And then I also have to multiply that by ln of 7. All right, now I have y equals sine e to the 3x. I have to use my chain rule to solve this. So my outside function is sine. So the derivative of sine is cosine e to the 3x. Now I do the derivative of the inside, which I would just repeat and say e to the 3x. Then I have to do the derivative of 3x, which is simply 3. Now again, I'd probably rewrite it just to make it a little bit prettier, and I have y prime equals 3 e to the 3x cosine e to the 3x.